Hello everyone, this is Mr. Edmund So. Today we are going to talk about HKDSE 2021 Mathematics Core Paper 1 Session 8 to Question 12. Please notice that here is a very important message. Now if we go to the polynomial question, we want you to do a little bit revise of this reference page, such as a division algorithm, remainder theorem, and factor theorem. For part A, what we have now is some information about a polynomial px. If it gives us the divisor, quotient, and remainder, we can use these three things to form the dividend. As we know that from the question x squared plus x plus 1 is the divisor, and 2x squared minus 37 is the quotient, and cx plus c minus 1 is the remainder. According to the division algorithm, we can form it in this format. The first thing is we need to find c, and we also have the information that px is divisible by x minus 5. When we set x minus 5 to 0, we have x equal 5, and we plug it into the polynomial, we will have the remainder 0. Then we set the equation, and we can calculate c. At the end of the day, c is minus 67. That is easy. And the easier thing is in part B. We need to prove that x plus 3 is a factor of px. So we do it again. We set the divisor x plus 3 to 0, and we have x minus 3. When we have x equal minus 3, we will have p minus 3 equals 0. That means x plus 3 is a factor of px. This is according to the factor theorem. Now we go to part C. We have someone's claim that all the roots of equation px equals 0 are real number. What we have now is only the px. However, it is not in his simple form. What we need to do is do the expansion and then simplify it, and now we have something uncommon. In this kind of situation, we usually deal with cubic polynomial. However, this time the highest degree of px is x to the power 4. That means we have bi-quadratic polynomial. Is this very difficult to do it? Yes or no? Because we know non-division, that means we will use one of the factor x minus 5 to divide it. And then we will have a cubic polynomial. That means we are back to the normal. There is another factor x minus 3, so we do the non-division once again. We can have our quadratic polynomial. And now the px is in the factors form. We have 3 factors. You may ask, what happened next? I tried that 2x squared plus 6x plus 7 cannot be factorized. I'm sure you are familiar with the discriminant b squared minus 4ac. When we plug the number, we have minus 20. As we know, if the discriminant is less than 0, we don't have any real roots. So we have to conclude that the roots of the quadratic equation are not real numbers. So we can disagree with the claim. Should you have any problem, please feel free to contact me. I would like to present you this verse, as I can only teach you a little bit knowledge, but God teach you life. Luckily, we can see each other in the following church. Goodbye.